This lesson is on one variable differential equations. And what are differential equations? Those are problems where they give us a derivative or a second derivative and we work backwards and we actually find what that c is. So when we do an indefinite integral, we always put plus c on the end. Now they're going to give us information to be able to figure out what that number is. So if we look, let's just be reminded of some derivative notation. Derivatives can be y prime, dy over dx, f prime of x, can be the velocity equation. Second derivative can be y double prime, d squared y over dx squared, f double prime of x, or the acceleration equation. And there are more, but these are like our typical ones that we're going to work with, so I just wanted to remind you of those notations before we moved on. Okay, and so our first example, we have a derivative equation, and they're giving us information about the original, and that's usually how you realize that it's a differential equation problem. When this y of 3 equals 5 is given to you, sometimes you just want to think of it in function notation, other times you want to think of it as the 0.35, but we'll end up using it in a minute. So the first thing that we want to do is take the antiderivative of both sides. And so if I take the antiderivative of dy dx, again, this is our derivative, so our original would be y. We have to think a little bit harder for our sine x plus 2. We have rules for that. So again, we're just backing up and saying if this is the derivative, then the original is the antiderivative of that. And so antiderivative of sine would be negative cosine. Antiderivative of 2 would be 2x. And then because this is an indefinite integral, we would put our plus c. So once you have that figured out, then you're going to use the given information to figure out what c is. So they gave us an x of 3 and a y of 5. So I plug the 5 in for y and the 3 in for x. And I'm going to solve that information and get c. So I'm going to hold off on this cosine because 3 is not from our unit circle. But 2 times 3 is 6. And I can subtract that, so I get a negative 1. But I'm trying to solve c, so I'm actually going to go ahead and add that cosine over too. And so negative 1 plus the cosine of 3 is our c. Now I can get that as a decimal if I need to, because I could type that into my calculator. You may be given stuff from the unit circle that you can figure out, but I'm going to leave it like this. It's not bad to leave it like this. You're not rounding off. It's not terrible. But what your goal is to get that original equation. So what we have right here, except instead of the c, we want to plug in what we know that c actually is. So your answer will be negative cosine of x, or y equals negative cosine of x, plus 2x plus 1, excuse me, that's a negative 1, plus negative 1 plus the cosine of 3. And so that's your final answer, is the actual equation with the c plugged in. And things are wanting to disappear on me today. So there we go. Let's move to example 2. Okay, in example 2, we're given a basic derivative equation, and they're telling us that f of 0 is 4. So again, 0 is our x, 4 is our y. This is a point on the original function. They've given us the derivative function. So if I take the antiderivative, my original function is the antiderivative of x squared dx, and then we'll find what c is. So take my power rule and get a 1/3 x cubed. Don't forget your plus c because that's our point today. Plug in 0 for x and 4 for y, or f of x in this case. So 4 is going to equal 1/3 times 0 cubed plus c. And 0 times anything is 0, so c is actually 4. And so when I go back, here's the equation that I'm looking for, but I'm going to plug in for c. So my answer is going to be f of x equals 1/3 x cubed plus 4. So that's my goal there. And notice, if they're using f prime and you back up, it's f. Before we were using dy dx, we backed up and it's y. Try to stick into that same notation as the problem. Okay, number 3 is a good one for you to try, and if you want to do that, go ahead and hit pause. Alright, number 3, if I take the antiderivative of f prime, I just have f. And then again, I'm going to think about the antiderivative of the square root of x. And since I'm doing a square root, I'm going to think of it as a power of 1/2. So I can use my power rule and get 3/2 here and a 2/3 here, and my plus c on the end. If I plug in 1 for x and 8 for f of x, looks like this. And 1 to any power is 1, so 1 times 2/3 is 2/3. So I really have 8 equals 2/3 plus c, and then I want to subtract that 2/3, and I'm going to go ahead and just use the fact, or the common denominator, so 8 would be 24/3 minus 2/3 would be 22/3. And my original equation is right here, so I'm going to plug this c in. So I have 2/3 x to the 3/2 plus 22/3. And so that is the answer for number 3. And hopefully if you paused and tried it on your own, you were correct. Okay, for our last example, I'm going to take it a little bit further. This time we're going to start with a second derivative. They gave us information about the derivative and about the original. So I'll be able to get both the equation for the derivative and the original. I just have to do this process twice. So if I take the antiderivative here, the antiderivative of f double prime will be f prime. And so f prime of x is again a power rule. So I'm going to have just x squared plus c. Then I'm going to plug in the information about the derivative. So they say when x is 0, y is 1. So our derivative is 1 when x is 0, and so c is 1. And that makes f prime of x actually be x squared plus 1. So if I come over here, let's do it again and back it up one more step to f. So the antiderivative of f prime would be f. So f is going to be the integral of x squared plus 1. And again, it's simple power rule, 1/3 x cubed plus x plus c. Then when x is 1, y is 5, so I'm going to say 5 is equal to 1/3 times 1 cubed plus 1 plus c. And 1 to any power is 1, so I have 1/3 plus 1 plus c. 1/3 and 1 is 3/3, so 1/3 and 3/3 is 4/3. And if I subtract my 4/3 from 5, which is 15/3, so 15/3 minus 4/3, I'm going to have 11/3 as my c. And that was the c for the original equation. So f of x is going to be 1/3 x cubed plus x plus 11/3. And so here is my original equation. If they would happen to ask you for your derivative equation, we found it right here. We found both of those based on the given information and this process. So you can start with that second derivative. And that concludes this lesson.